Hey everybody, I was getting ready to transfer this next video up to the computer and edit it for uploading, and I just thought I'd do a little preface here before we did this. In this video, the main thing that happened was the output transistors were shorted, and I had to replace them, and I had to go about finding a suitable replacement because the ones that were in there, well, I can still get them. They're still available. There's a couple of old parts stores here in the States, and one of them is only about 4 hours from where I live, and they had several of them in stock, so I could have ordered originals. And they're these MT200 type transistors, kind of funny looking things, but these were real common in the 1980s. And long story short, I decided to use some transistors that I had in stock. I made a comment that they are still very plentiful and available because the last time I purchased them, they were. I did a quick check online, and at least the normal haunts like Mauser and DigiKey are showing that they no longer sell them. Although I'm sure you can still find them at many other sources. So I just wanted to kind of let you know this is a really good example of what we've been talking about in the last couple videos, finding a suitable replacement transistor. If somebody tells you in a video to use that this is a good replacement, and then you go to purchase it, don't be surprised if that part is no longer available or is out of stock or any other number of things. It's just the world we live in right now. So that's where you kind of have to use your skills to find a different type of transistor. But that's just what happened in this video. But I did have a really good, what turned out to be a good replacement, and I explained why. And hope you find it interesting. I sure did. And I sure love the way this thing turned out. So without any further ado, let's get started. Well, the year was 1981, and as most aspiring young up-and-coming nerds, I went out to my local Radio Shack and got the new catalog and flipped through to see all the new things that they were coming out with that year. And I got to the page where this came up, and I saw those meters, and I saw the big shiny faceplate and these knobs, and I was like, wow, and it lights up green. And I said, that is the coolest looking stereo. So what it is the STA-2080 by Realistic. And these are a little bit of a sleeper. That was definitely eclipsed by the STA-2100 or 2100D, which was 125 watt per channel toroidal transformer. It really was built to compete with the Pioneer SX-1050 and that genre, the Marantz, what was it, the 2125 or something like that. So there was quite a lot of hype about this. There was a lot going on at the time with all the stereo wars and the power wars and all that. And this thing came out, and it was just, I thought it was always better looking than the 2100. And since it was 80 watts per channel, back then, watts was everything. Nobody really paid attention to anything else. And this one kind of never got the recognition that I think it should have. It's a very solid built receiver, but I've always wanted one. And they do come up occasionally, and sometimes you can get a good deal on them. But it's usually hard to find one in good physical condition for what I would call a fair price, because of course this is just something that would be good for the collection. I think I'm going to keep this one, and I may even use it on and off sometimes. We'll just see how it goes. The other thing I'm interested in is how it compares to the STA-2000, which was a 75 watt per channel receiver that preceded this one. It was kind of in that same range, model range, and that's a fantastic receiver. So being this one's later build, it's into the 1980s, I'm wondering if maybe they kind of went backwards on their build quality, but picking this thing up, you wouldn't know it by the weight. It's pretty heavy. So I got this one. My friend Dave, we've talked about him in the past, who kind of procures a lot of this stuff for me. He found this and texted me and said, "What do you think?" And I said, "I think that's a good candidate to get on the bench." So he worked a deal out with the owner, and well, here it is. So cosmetically, it just needs cleaned up. According to the owner, the only thing he told me, won't power up. Well, judging by the smell when I opened it, this could either be a smoker's choice, or I could be smelling the smell of expired electrons. We don't know yet. Well, plug it in and see what it does. All right, we're connected to B+ and ground. And let's turn this on real quick and see if it charges through the bulb. It would help if I turn the power switch on here. And nothing. Absolutely nothing. Okay. Well, it's kind of hard for the electrons to jump from there to the back of the fuse holder without a fuse. So that's not a good thing when it blows the fuse like that. So let me find, what is this, a 7 amp 125 volt fuse, and we're going to definitely keep this thing on a tight leash. Okay, we have ourselves a new fuse. Okay. Now I have a feeling the dim bulb is going to not be a dim bulb. It is going to be a bright bulb. So let's see what it does. Oh yeah. And there is absolutely no output whatsoever. So, what do we have? Do we have a dead short on the power rail on a transistor, and it's shorting a power rail? Or what do we have? So the first thing I'm going to do is we're going to suspect the big power devices first. None of the fuses down here appear to be blown, but of course I haven't looked very closely. Let's see. I mean, yeah, those fuses all look to be intact. Of course I haven't measured them, but so the low voltage power supplies have survived. Let's disconnect. I'm going to unplug this. Let's disconnect these two. Take a look here. We'll pull out this and this. And the first thing I want to do is make sure that the negative, the B-, did not charge itself up, because I think that would be rather unpleasant for me to put my fingers across there. Let's see what it does. I'll probably just grab it over here. Nope, there's nothing on there either. Okay, I have those disconnected, and I have this very carefully separated. Hopefully it won't short out on anything. It doesn't appear to be. We have the bulb just in case. I'm going to turn this on for a second. And there it goes. It's charging up. So I'm just going to let that bleed back down. I didn't leave this on long enough to charge up very far. But you can see, just by disconnecting the power from your power amplifier boards, these capacitors can charge up. And if they can charge up, that means we have a short, and it's most likely one of these transistors. And that's not the best news in the world, because these are what's called MT200 transistors. And MT200 is a case type. If you look down here, you can see one. And unlike a TO3P, which has one screw hole in the middle and is kind of an elongated transistor, you have these ones which are a wide transistor with a screw on either end. So it's a larger case, a bigger flange to get more heat onto the heat sink better, so it's more efficient. these weren't made for a very super long time. They really got popular in the 1980s, and right now they're rare as hen's teeth to find original replacements. But we can replace these with a TO3P, and we'll have to make a adapter plate to be able to mount them in place of these. It's all possible, we can do it, but just take a little extra work. Okay, I've unplugged these, and now, and of course the power plugs are already unplugged, so now we're going to flip it up and look at the underbelly, and I think these are going to drop out from the bottom. Oh no, isn't that an oogie mess? They really like that silicon carny crap, whatever you want to call it. So I will have to remove those. What these are is these are the thermal sensors that sense if either of the heat sinks gets overheated. They get overheated, the little bimetallic strip opens up, and these actually lead to the power leads to the transformer. So basically they just don't want the transformer to overheat, or they don't want the amplifier to overheat. So that cuts power to the amplifier, or to the amp modules if something overheats. All right, let's get this last module out. And those are easy to take apart. I wish they were all that easy to work on. So far, service friendly. Okay. Well, do we have just one bad transistor? One or both on one side, or both sides? I'm going to say one bad transistor. I don't know. But that will cause us to have to replace all of them. I probably should take this off first. The thermistor. Okay. I mean, these boards look perfect. They need cleaned up a little bit, but okay. Well, we just did some transistor videos. How do we test these? Let's check it out. Okay. Help to plug some probes in here. Okay, I think it is base collector emitter. I don't know if this is the NPN or the PNP, so let's start with NPN or PNP. So I'll put the base, I'll put the positive there. Okay, we have a voltage drop. And we can see from base to this one is 536 millivolts. And base to this one is 541. So what's our rule? The larger voltage is always the emitter. So this is base, collector, emitter. And since we're going NPN, then this one must be PNP, so we have to switch our leads around. And let's see, base, and then this is going to be the collector. So far that's good. So 587, 588. So just a little bit more. See that? So there's your emitter. And so far these transistors look to be okay. So we don't have a short there. Okay. Oh, take a look at that. So these ones are backwards from those ones. If you notice on that other one we tested, when I tested that, the pins were on this side and the socket was on the circuit board side. So that's interesting. Okay. What does the board say here? Yeah, base. Look at that. So 40 reads the same both ways exactly. That's kind of weird. Aha! We have a shorted. And I didn't check on this one for the emitter collector. I forgot to test those. I'll check emitter collector on that side, but that transistor shorted. Oh yeah. Bad transistors. So, you know what that means. We're going to have to find some replacements. All right, so here is the transistor that we're looking at. And if I zoom in, you'll see that 140 volt collector to base, collector to emitter. 5 volt, I mean, all this stuff's pretty basic. Collector current continuous 10 amp, 15 amp peak. It's 120 watt dissipation. And if we look here, gain the transition frequency is 15 megahertz, which is kind of a middle of the road transistor for an output. You know, you go into the MJ series, most of those are around 4 megahertz. And you get into some of the really high-end Sanken transistors, they can be upwards of 30 to 50 megahertz. So this is kind of in between, so it's a decent transistor. I'm not sure if the negative feedback circuit on here is such that I have to adhere to this very tightly, but I don't know. Current gain on these at 50 milliamps, 5 volts is pretty low, and you can see these are gain sorted. So there's the S suffix is going to be 40 to 80, an R suffix is 60 to 120, and a Q suffix is 100 to 200. And I don't know what these ones are. D745, and it appears to be a letter R on both of them. See, RBYA. Or R8YA, I'm sorry. So I'm assuming that means that's a relatively high gain bandwidth product for an output transistor. So we're going to have to look and see what I have. I looked online, and on eBay I found a whole bunch of these, both the 745 and the 2SB705 complement. And actually a company that's over in Ohio, which is, it's about a 4-hour drive from where I live, and they advertise that they have a few of these left in stock, new old stock ones. So I could order those. They want about 12 or 13 bucks a piece for them. If I only buy the two, that's going to be about 26 bucks plus shipping. If I buy all 4 of them just in case there's something wrong with the other ones, which I would probably want to do, you're looking at, you're looking at about 60, 70 bucks, 75 bucks all in maybe, which isn't too bad. Now the other question is, what do I have in my stash? I know I don't have any MT200 type cases. I know I have TO3Ps. What I don't know is if I have something similar or superior to these. So let's see what we got. Okay, so here's a few candidates I came up with. So I can order those ones, and it shouldn't be a problem, and they'll be in a couple days. The problem is that they only have a few of them left. There's probably like 5 of them left of each in stock. And once they're gone, they're gone. And there are some other ones out there, so they're available. But what are we going to do if they're not available? And also, what if I just don't feel like ordering them? So here's some candidates. First ones we could do would be these MJ21193 and MJ21194. These are like way overrated from these. They're probably a better quality transistor in every way, shape, and form, except for the transition frequency or the gain bandwidth product. So let me look up a data sheet here, and I'll show you what I'm talking about. Okay, so the first thing we're looking at is this MJL21193 and MJL21194. And looking at this, it is in some ways much better on the surface. They're 250 and 400 volt for VCEO and VCBO. So, your breakdown voltages are much higher than the 140 volts of the original. It's a 200 watt dissipation instead of 140 watt. The collector current continuous is 16 amps versus 10 amps, and a 30 amp peak versus 10 or 15 amp peak on the original transistor. But then things start to get a little bit crazy. So if we look at, for instance, the gain, let's look at transition frequency first. 1 amp DC, 10 volts at 1 megahertz. And this would be 0.2 amps, 5 volts. And it's saying 15 megahertz, and it's saying with 10 volts, it's saying this one is 1 amp, 10 volts, 1 megahertz, 4 megahertz. So maybe because they're measuring it at a different, at a different point, there's a possibility that this might work for that. Okay, I have decided for multiple reasons to go with the MJL 21193 and 21194 as replacements. As I said before, with the exception of the gain bandwidth product, these are pretty much superior in every way, shape, and form to the originals. Now, before you all get excited about this, couple good things I found. Number one, if I fold these pins up and put them in here just like the original, they perfectly line up. If you look at the spacing of these mounting holes, they're exactly on either side of the transistor. See that? These transistors are insulated all the way around, so the screws will never contact the plate on there. And I can use an MT200 pad just like that and center it in there, and it will properly cover everything. You can see. Now, I can also use some other insulators that I have that are even better, and I might do that. I'm not sure. But when you look at this, I will be able to use the original mounting holes. And what I'm going to do is I'm going to cut a strip of this aluminum bar stock, and I'm going to pop 2 holes in it like that. And I'll make these little stiffeners. You can see how thick that'll be then. And then that way, when I screw this down on either side, it'll put pressure on this and hold it against the heatsink. And that way, it'll be a drop-in replacement. Now, I'm going to show you why sometimes blindly following numbers on a data sheet can lead you down a rabbit hole. Now, I didn't go so far as to do charts and so forth, because that would be way too much to figure out. But if you look at the gain bandwidth product on this, you would think that this is almost 4 times the transition frequency of the original transistors. But the devil's in the details, as they say. If you look, the test that they did was at 1/5 of the collector current of this one and 1/2 of the collector emitter current, or the collector emitter voltage of this one. If you increase the current and voltage to be the same test result, or same test parameters as this one, all of a sudden this will drop pretty dramatically. I'll zoom in a little bit. So the transition frequency of a transistor, it'll typically decrease as the collector current increases. And that's because the collector current increases the rate of the recombination of the carriers in the base region. What does that mean? It basically means that it makes the transistor more likely to conduct, and it reduces the transistor's gain. So the FT will decrease also as the collector emitter voltage increases. So when you double the collector emitter voltage, it's no longer going to be 15 megahertz. So what I'm saying is, if you had a way to test, a test frequency and a gain product and everything, if you set up a test jig to do that, and you set up the same test parameters for both transistors, I think what you'd find is they're both very similar. So what's going to happen is, conversely, if I reduced the test current and the test voltage of this transistor, of our new one, you would see that the gain would be higher than 4 megahertz. So it's deceptive. You may think that this is, a lot of people get down on these transistors here, these MJLs, because they're very plentiful, they're very affordable, and they're very consistently built. ON Semiconductor does a really good job making these, and you can get them. That's the beauty of it. But a lot of people are afraid because they see these older transistors with these fantastic numbers on them. But it's because of where they test it that they have such a fantastic FT number. And they don't really realize that this transistor is basically going to do the same thing if you reduce the test parameters that far. So I hope that makes sense, and that is why I made my choice the way I did. We're going to put these in, and we're going to just see if what I'm saying is correct. Okay, I went down to the shop, and this is what I came up with. So I found some 1/4-inch thick aluminum plate down the shop, and I was able to run it through the fence on the bandsaw, and I just cut them into these strips and just kind of smooth them a little bit on the edges with a smoothing file. And then I used these countersink end mills. These are great if you for doing this. It lets you cut the pockets for the screw head to recess into. And all it is a little cutter that follows the original pilot hole, and then this end mill, which has some garbage on it, cuts down and just cuts this little pocket in there like that. And you can buy them in all kinds of sizes. High-speed tool steel, and some of them are made out of carbide. Just depends what you get. And you can order these on Amazon, eBay, a lot of the tool stores like Granger's and McMaster-Carr and places like that have them. And I have a set of these. They do a really good job. You can use them with a hand drill, but it's pretty awkward, and I don't recommend it. But you can do it if you're careful. But it works a lot better if you have a drill press and a little clamp to hold it or something, or a little vise of some sort. But anyway, what that's going to do is that's going to allow these screw heads to sit flush. And did I need that? No. But I just think it gives it a little bit of a finishing touch. And these are stiff enough that when we line them up on here, you can see the screws will just go right through it like that, and like that, and it'll just clamp it in. And what I can do is this will fit right in between there like that, and that'll clamp it down on there. And then I have these really nice high quality sill pads, which will actually outperform the mica and the interface compound. And it actually works better than that. So I'm just going to remove these bad transistors, put these ones in this place, and I think we're going to be good to go. And that's what the finished product looks like. I think it's a pretty good fit. Those are tight. So yeah, I think this is going to work out real well. Let's turn it on and look at it dim down. That's what we want. And you can see not too bad. And you can see as it warms up, it's dropping. So our DC offset, you know, for a module that does not have an adjustment, that's pretty good. I mean, 15 millivolts, that's pretty good. Now let's turn this on. I'm connected across R519 on this one. And remember, we did get good DC offset. So now let's see if we get any kind of a bias. And we do not. There is no bias reading whatsoever. So it tells me that it's either way, you know, adjusted way too low. You can see it's kind of creeping up a wee little bit, but I mean, we're talking microvolts. We're at 39, 40 microvolts. So let's turn the pot and see. What we're supposed to have is about 50 millivolts. Or no, what they say, they want 10 millivolts into an 8 ohm load. So I do not have an 8 ohm load. Let me put that on there first. All right, we have 8 ohm load on the output. And now let's turn it back on and see if we see any bias now. Okay, I hope I'm on there. Looks to be. All right, let me turn this back on. Okay, nothing that way. Let's go the other way. Eventually you should see these turn on. There it goes. And they're saying they want 10 millivolts. Okay, now it's turned on. We were just misadjusted, that's all. Turn that down. And of course that will move around a little bit until everything warms up and stabilizes, but you can see the bias adjusted right up. Okay, digging in a little bit deeper into this other amp module, the two screws that hold this circuit board to the frame of, you know, the heat sink are missing. So these were definitely replaced. And this amp was worked on, and I bet this red paint was someone marking them after they tested the transistors to make sure that they were still good after they replaced the outputs. So the outputs went on this one, and more than likely these resistors must have opened up. Maybe, I don't know, and that's why they were replaced with different resistors. Same thing with these two here, although these could be factory. They don't match everything else, but they could be, and this pot has been replaced, I bet. Although the soldering job is extremely good, because it doesn't look like they cleaned the flux, and it doesn't look like it's been ever soldered on. So maybe these are, you know, original parts, but it is kind of strange. We'll measure everything, make sure it's all good. But take a look at this. I pulled this off. These are definitely replacements, and these are really good transistors. These are two SC2921 and two SA-1215 by Sanken. And if these are originals, which I think they are, those are excellent transistors. And you can see they have been replaced, but whoever did the work did pretty good soldering work on this thing, and they did very good work. So I think this module has been rebuilt at one point in time. These are actually better transistors than these original NECs. They are the same wattage and voltage pretty much, but they have a higher transition frequency and so forth. These Sanken transistors are excellent, and these are probably the LAPT style transistors. I'm not 100% sure, which are high-speed transistors. They're designed for audio, for high-performance audio, but I'm not sure. I'd have to look it up. But these are good transistors. I am still going to replace them with the same ones that are on the other side so everything matches. I'm really I'm really a stickler for that. That may not be necessary, but I want to do that. Definitely replaced. When I got this off, I noticed that the rings, the pads, are broken off on 3 of them, and damaged on this one. And I wondered why there were such big solder blobs on there. That's why. They just had it blobbed onto here. So we're going to have to put a proper patch on each of those, which is some extra work, but we need to do that to make sure that it's reliable. Okay, you've all seen me do this before. I just take some of this hobby copper sheet and I cut off a strip, and what we're going to do is make some nice straight pieces that will fit, and I cleaned these off as best I could. And I'm going to make 6 little strips in there, and I'll clean off the solder mask there. We'll put those on there and tack them down, and then we'll solder them on this end through these pins, and then we'll put our new transistors in, and it should be as good as new. Okay, the second module is in. Let's take a look here. Turn it on. See if we get some light. Perfect. And let's see what kind of offset we have. Not too bad. It's a 31 volts. That's not good. Bad. So we obviously have a problem here. It's not, you're getting one full rail on the one side. So that tells me that either I have something wired incorrectly, or one of the other transistors is shorted. Okay, false alarm. I got ahead of myself. This was unplugged. I didn't plug it in yet. Now that I have it connected, let's turn it on again. And now we're down to millivolts. Look at that. Ooh, that one's even got lower offset than the other channel. That one's really good. All right. Okay, checking bias. We still got this on a pretty short leash, so, and you can see it's doing the same thing as the other channel. I just think these transistors need a little bit more drive to them. Not too much. Remember, this is like a 10 or 15 turn pot. So I'm really not moving it as much as you might think. That's good enough. That's good for now. So sometimes you get fooled into thinking you have an easy problem. It's just an output transistor on one channel, and you replace those and you got it made. And you get everything hooked up and ready to test it, and what do you find out? The protect relay doesn't come in. So we're going to have to troubleshoot that. We know that we don't have excessive DC offset on either channel. We know that the bias was able to be adjusted on both channels. So we know the amplifiers are working well. What we don't know is if the rest of the power supplies are okay. Now, I don't see anything just looking. I don't see anything that looks to be burned or blown or shorted or whatever. You can't always see a faulty component, of course, but right now I'm not seeing anything that's leading me to believe that there's any kind of catastrophic failure in here. Okay, go through the power supplies. Pin 1 is ground. Pin 2 is minus 31 volts, and I'm on the dim bulb, so it's current limited right now, so we don't have full voltage, but that looks good. That would be the minus 31.1 volts. Pin 3 is your minus 22. That's pretty close. 4 is going to be minus 22 also. 5 is an AC line, 6 AC line, 7 AC line. 8 is going to be plus 22. And those are a little bit low because I have a low input voltage. 9 is the 24, and then 10 is the 31. And they're all kind of, one's bigger than the other. So the voltages are all there pretty much. Pins 13 and 14 is right here. Yep, that's good. They're all a little bit low, but again, I only have 89 volts instead of 120 volts going in there. So those power supplies are good, and it might be that our relay isn't coming in. Some of these protect circuits have to have full power before they'll pull in. Some of them, once the caps charge up, they'll pop, but maybe that's what's wrong here. I don't see anything that's loading anything down, so I think it might be safe to go to full power. But before I do that, I'm going to turn this thing around the other way because I want to be able to observe those relays. kind of zoomed in here, and I hope the camera will pick it up. And looking over here, and what's interesting about this circuit is you have 2 relays in here instead of 1, and it's not. You would think that 2 relays would be for the right and the left channel, but it's not. There's 1 protect relay for speaker A and 1 protect relay for speaker B, and strangely enough, they're in parallel. They're pretty much in parallel, other than the speaker select switch will, can bring one relay or the other in. So instead of selecting the speakers through the switch itself, when you do speaker A or speaker B on the front panel, it pulls in the respective relay, and that relay also acts as the protect relay. And I can't get either one of them to pull in, so it kind of gives me the impression that that this circuit over here is not working. So it could be over here. There's also an SCR that will pull down the power to the main amp, and that's a very unique circuit. This is a very unique protect circuit. If you read the theory of operation on it, how it works, it's a little different than the traditional ones you see in most stereos from this era. But for whatever reason, these aren't pulling in. So I think I'm going to put full power to it, and we're going to see if we can get this to operate. Okay, here are the relays, and they're kind of funny looking relays also. I don't know if this camera is going to focus for me or not. There. You can see them. They're really odd the way they're pinned out, so we'll have to get kind of creative if we have to replace these relays, but I don't know if they're the problem or not. I'm going to turn the power on. They do not pull in. I can select either one, and they don't do anything. So let's go to full power and see what happens. Ooh, they clicked. Did you hear that? You can see it right down here, maybe. Okay. So that's all it was. This amplifier is one of those ones that it has to have full voltage or it won't power up. So what I'm going to do now is I'm going to shut this off for a second. I'm going to connect the meter back up, and I'm just going to verify the bias doesn't go way up now that I have full power to it. Okay, so the bias went way up when I put full power to this. So right where I had it when I measured it probably is where it should have been. But since we were on that dim bulb, that's why it wasn't reading anything. So this amplifier is one of those ones that really needs the full 120 volts before it can work properly. But that's okay. Okay, let me see if I can adjust this down. I mean, it's going to be right where I left it, where I started out before I adjusted it. Did I keep slipping off of the potentiometer here? There we go. Okay, and I'm just going to adjust this to about 8 point something. A little bit low, because I figure once it heats up, you'll get a little bit of bias creep from the heat. So it's good right there. Okay, we are now ready to test it. Right there is the whole reason I loved these things when they first came out. That green display and these big meters and the way they're kind of centered on there. It just, to me, this was a beautiful, elegant looking receiver. It wasn't the most expensive one out there, but I just liked it. So I have a 1 kilohertz signal going into it now. I have the dummy load connected. We have our oscilloscope on there, which I need to put that anti-reflective thing on that too, because that really worked on the other scope. Okay, let's see what happens if this thing has an output. It appears to. And both channels, look at them track. Wow. That's pretty impressive. Very impressive. Okay, there's your, I'm at 10 watts per channel, so that would be 80 watts would be at the very top. And the meters are not correct right now. They're a little bit, they're not reading. They're going to need to be adjusted, but I'll tell you what, this thing, I don't know where it's going to, there it goes. And they're both clipping perfectly. Wow. How about that? That's really nice. It works. Okay, that's exciting. Very exciting. All right, well, I'm going to let this cook for a little while, and we're just going to see how the heat sinks warm up, and if these transistors are happy in this circuit. And if they are, I'm going to hook up some music. I like it. I think it's working well. And we really didn't need to do a whole lot to this one to get it working. Basically down here is all we replaced. So here are the ones that were shorted. Well, these are originals, these NECs. And then we had the Sanken 2SC and 2SA that were replaced previously. These must have been, I mean, these were the originals, and they replaced this side. And I replaced the bias pots. This one was still good, but this one was getting kind of, I don't know, it was getting worn out. And I replaced the capacitors and the amplifier modules, and that was it. But it's working fantastic right now. And man, I really like this faceplate. I like the way this thing's laid out. I like these big meters. It's just a nice looking receiver. So I'm probably going to go ahead and replace the capacitors in the power supply at least, and I'll do that off camera probably. If any of you are interested in seeing any more of this receiver, let me know. If I get enough requests, maybe I'll do an extra video, but this one's for the most part done. I'm going to clean it up and so forth and put it back together, but other than that, I think it's good to go. So until next time, I wish you all peace, joy, happiness, and good health in your lives. And we'll be back real soon. I have many other projects to do, and I have 2 of them I'm looking at in particular right now. And I'm just trying to decide which one I want to see, which one I want to do next. So until then, stay well, everybody, and we'll see you again real soon. Take care. Bye-bye.